This is the first one. This is Fips 203, 204, 205. I have a feeling I'm going to want some code. Years old. This is an incomplete implementation of Ml-Kem, but I'm laying the guts of it. This is the actual update to the Federal Register with a little bit of context. It's not key exchange, it's not key agreement, it's key establishment, and then signatures. I'm gonna get pedantic about Kyber versus Ml-Kem and dilithium versus MLDSA. If you have any problems, go dust it. I got too loud for the sleepy puppy, and now he has to move. I wish I could show you this extremely cute dog, maybe next time. This poor computer. This MacBook is at least 5 years old. I need to replace it. Quantum computers. Junk now. This took almost 8 years. This has been a long time coming. I was telling a civilian about this today. And I don't think I quite communicated how long we've been waiting for these fucking little documents to drop. There were 80 plus submissions, and only 69 were accepted. Because I've been telling people 80. Recently, I saw other places that were like, there were 69. I remember 80 plus. Some of them did not, qualify. So, let's see. Blah, blah, blah. Blah, blah, blah. Yeah. And then we went to 26. It wasn't even give us chems, give us signatures, give us this, give us that. They were just like, give us a bunch of shit. And then eventually they turned it into life under the virus. I saw the validator people have some test vectors. You have to go somewhere else besides the Fips document packages. They have a repo on GitHub now. I think they sent mail to the PQC forum list. I'll try and go find that later because the validators at NIST have said, like, we have updated some stuff and we're ready to start validating implementations of these 3 algorithms. Fun years. A lot of breaking, building. That was 2019. Are the test vectors in the Fips or does that include the other validation thing? We just updated our draft for X-Wing with new test vectors for Ml-Kem specific. I have empathy for people who generate test vectors, but now they're going to go in NIST errata. People don't read the errata, so that sucks. Most promising candidates. Second round. And then the 7 final and 8 alternates. And that included one of my favorites, the top. Yes. Part of the reason why we don't hash in the ciphertext in Ml-Kem anymore. Gotcha. That's rough. The ACVP, CAVP, whichever order it's supposed to be. That's really annoying. I wonder why they did that. Maybe because they're optional? I have to go. I've been holding off on these documents until now so it can be fresh, novel, and interesting. Free stream, free chatter. All this happened during deep COVID. The only chem we have and the 3 alternates are still floating around. This is cool because they say somewhere else that we could have guessed, but it wasn't confirmed, that Falcon is going to be Fips 206. And it will be FN DSA, but that's still scheduled to be later this year. That'll be interesting to look at. Sphinx will be capable of protecting U.S. government information into the foreseeable future, including after the advent of quantum computers, especially the Ml-Kem stuff. CNSA 2.0, which the NSA says national security systems like top secret classified information will need to be Ml-Kem 1024 alone, not hybrid. That's the big endorsement for trusting Ml-Kem. Yep. Ml-Encapsulation derived from, not the same as Crystal's Kyber. It's gone through several notable changes since the original 2nd and 3rd version of the Crystals Kyber submission. So if you want to be a post-quantum cryptography pedant to your friends, you need to go, are you talking about Kyber, Crystals Kyber, or are you talking about Ml-Kem Fips 203? Because those are not the same thing. Because you are technically correct, which is the best kind of correct. Key establishment, shared secret between two parties. Spoiler warning, they've hard-coded the shared secret to 256-bit. You can't do bigger or smaller, all the parameter sets for Ml-Kem. That's discrete log, and that's RSA. Dilithium and stateless hash-based signatures, aka Sphinx. It's not just about like which thing you're going to talk about. They have different security properties. They are different in terms of security properties. They are not interoperable. It matters which you're using because it gives different security guarantees. Decisions about your crypto system, like your protocol, matter about which thing you're getting from Kyber and which thing you're getting from Ml-Kem to design the rest of it and to give some sort of security proof of reduction. It makes you have to know those things to make choices about the rest of your whatever else cryptography you're doing. In the future, Fips specifying digital signatures to Falcon, yes, is an alternative. We already have XMSS, the other stateful hash-based signature schemes, which are harder to use than Sphinx, now stateless hash-based digital signatures. People are confident in those. That's Fips 205. Published a notice in the Federal Register last year. We have the comments. That's good for public transparency. I'm assuming this is from the comments on the initial public draft and not the previous versions of Kyber. For reference, this is the initial public draft. This is the thing I've been staring at and ingesting for a year. It's almost exactly a year. I'm very familiar with this 50-page document, and now we have a new 56-page document with extra shit in it. So this is just sort of a review. Shake. Sure. And then I think they improved this. I haven't looked at the dilithium or the Fips 204 MLDSA thing yet. I hope they have a lot of consistency improvements between the final Ml-Kem and MLDSA. The nice thing about the crystals stuff, because they were like Ml-Kem and like Crystals Dilithium and Crystals Kyber are like sisters from another mister. They're so similar. They came from the same family, the same authors, the same paper writers. A whole bunch of stuff was nice because they're very related. The two drafts from Fips for draft Ml-Kem and draft MLDSA looked like they came from two completely different people. It was rough because you were just like there's a lot of shared stuff between Ml-Kem and MLDSA, like under the hood, the math and algorithms, that it was annoying that the two specs were so different, stylistically different. So hopefully they're going to look better. And I'm just going to get going because I don't have forever here. Jesus. We need existing documents that they have said in other areas how they're going to update them for things like KDF guidance and other things that we actually would like to have on the record from them if you want to make things Fips compatible. I don't think they're up yet. Side channels. Outside of scope. I'm pretty sure all the algorithms are constant time, but someone can probably check me on that. Other stuff like power leakage and whatever is, I think, out of scope for them. Interesting. Of SP857. A generic block cipher, not specifically AES, was described. Fips 203. Version of decaps not been sufficiently evaluated. Current generation step not modified. Failed checks. They are variable in the sampling. I don't know if the algorithms are specific enough to cover the case of these leaky divides. Architectures are weird. Yeah, I include validation steps for keys. That is nice to see. And I remember we were debating a lot of like, okay, if we're not going to make these changes, if we're not going to be able to make significant changes to Ml-Kem to get highly resistant binding properties, to get the shared secret to tightly bind to the public key and the ciphertext. Then we have to do extra stuff. Unless you're just trying to get everything else in your implementation to work, and you're like, I'm going to have real simple math and modular reduction just to get everything else working. And then with a big safety warning in my Rust code that says, to do, replace with real modular reduction, Barrett reduction. Eventually, I have not got to that yet. Now I have to rewrite half of my code because they removed some shit and they went from like bits to bytes and so on. One should. Especially because in the initial public draft of Ml-Kem, the implement field arithmetic, the modulus is only 308 or something like that. Easy to do school book modular arithmetic in a non-stupid way, as opposed to a 256-bit prime field for elliptic curves. Just you wait. You've got Fips 206 coming down the pike, and that's got your floating point for you. It'll be interesting to see. Now that this is finally landed, people have been implementing this for a bit. We've gotten some things like the leaky divide, and we think we fixed those, or at least we know how to address those. But it'll be interesting to see, now that it is officially a Fips, is officially landed, and it's locked, test vectors that need to be changed. I don't know how they handle that. See other people just sort of naively try to implement it, and what bugs come out, more naive implementations. All right, I'm going to get through this quickly. Now we have validation checks. When we were complaining about if you just do this as written, you don't get strong binding properties. And if you do it like so, you get everything you want for free. If they didn't change it, which it doesn't look like they did, is to validate your keys. Make sure they're well formed and check if you have an encapsulation key, check it and own the decapsulation key, check that they generates correctly. But there was no validation in the initial public draft for Ml-Kem, and now there is. Although they have a line that's basically like, just because this validation check passes does not necessarily mean that the keys were generated correctly. And I think that's because of sampling. You can validate the keys to make sure that everything is correct in itself, but that doesn't mean you sampled it correctly with the correct distribution. I think that might be difficult to have a detection check that's not too expensive, but we'll read more and see. Cryptography floating point is, I don't know if Pornin is still here, but Pornin is probably one of the few people I trust to get cryptography implemented over floating point arithmetic correct and secure. He has said it's really hard, although with an incredible Quebecois accent, and he's much less vulgar than I am. It's hard. I don't want to do it. I'm going to look at Falcon when it comes out, or whatever. FNDSA, Fips 206. I don't know. We'll see. Now that we have validation, which is great. The core algorithms are difficult to test because they're non-deterministic. They fix that. Now they have all this stuff that's like deterministic, and then you just wrap it with the wrapper that sources the randomness and shoves it into the internal function, which is nice. Readability, bytes and bits, language, byte strings, exception of shake. I hope so. This is funny because a lot of people paying close attention have been like, who's ever going to use 512? This is new, and attacks only get better. If you want to be conservative for the long run, why go with 512? Go with Ml-Kem 768. A couple of weeks ago, Meta put out a blog post being like, hey, we're starting to deploy hybrid TLS 1.3 internally, trying to move towards doing it for basically all of Meta, all of Facebook, Instagram, or whatever. And they said, we had trouble rolling out hybrid Ml-Kem 768. It was a little too big. And if we used Ml-Kem 512, it was fine. And it fit in our TCP windows and all this sort of, I don't know if they had weird shenanigans or just sort of normal TCP shenanigans, but they were like, yeah, 512, it's useful. People want 512 for a variety of reasons. And the people who are like, if you don't have to deploy 512, go with 768. If you don't have any constraints in that regard, you'll be good to go. Not overkill. Ml-Kem 768, pretty good. Whether the security of 512 will hold up, just because it's kind of like the bare minimum parameter set, we're not sure. I don't know. But it fits. It doesn't blow up your sizes and your frames and your packet sizes, so people need it. What about SHA-3 and TurboShake? Are they too big? Are they too slow? Are they not adopted? What's fun is there's lots of SHA-3 in here, in Ml-Kem. Very, very, very second half 2024. Too many rounds. JP Elmanson did a good talk at Real World Crypto arguing we have too much crypto. Too many rounds of, you know, what your internal round function is and your hash function, or too many rounds for your block cipher. Just too much crypto for the security that you need in practice. Which, good argument. For this stuff like this, I would not say that we're anywhere close to too much crypto for very novel stuff like this. Hopefully I'll be wrong and we'll be able to be like, we deployed all this 768. It's too big and we don't need it. The best known attacks in the world are way too expensive to leverage against 768. We can cut it down to 512 and have a nice margin and not worry. Great. Awesome. We might be a little bit too... got a thick armor out there for a little bit too much. One nice thing, Ml-Kem, the update for Meta, had some good stats that when they added Kyber 768 to X25519 for key exchange, they only got a 40% increase in computation costs, not 100% or even 50%. So 768 computationally is still cheaper than doing computationally cost, according to Meta, amortized over mostly TLS connections. It's cheaper. That's pretty cool. I'm excited about that got in there. Whether the choice of the SHA-3 and SOT wrap up your Ml-Kem and you have a nice blob, they'll be your Ml-Kem. You don't have to worry about your SHA-3, but yeah. We'll see if there's rumbles in practice, but you might have a KDF for your real thing outside of Ml-Kem. If you, like, inside Ml-Kem, you've got SHA-3 as your KDF. Outside of it, do your HKDF, HMAC, Whoosy What's It, SHA-2, all that nice construction. You can do cheap stuff outside and just worry about software or, like, intrinsics-based, instruction-based Whoosy What's It's inside your Ml-Kem implementation. We'll go through this. We want official on-the-record stuff about hybrids. I don't know if that's a new 800 series document. Any bets on second half? We are in the second half of 2024. I have no information to inform a speculation of when in 2024. I have no idea. I vaguely have a feeling that because there is no public draft for Falcon yet. And there are no public drafts for any of these. I don't know if they do that, but they have to do a public draft with Falcon. I don't know when that's going to come out, if it's going to come out. If I'm wrong about that, if there is a public draft for Falcon, let me know. But I'm pretty sure there is not. I would be annoyed if they lollygagged significantly on getting those other updated hybrid guidance, updated KDF guidance, updated SP 800, 56Cs, whatever. If they lollygagged on that, because, like, I got a question today, literally, about, like, how do I do it XYZ way? And I'm like, we think this is fine if you want to get this thing Fips certified, but we're not sure that is fine. So getting guidance will be nice. Yep, they fixed this little bug. I don't know if this is the transposing of the A matrix, but I will be rereading that now because I just implemented that. And I was like, I think this is fine. I hope it's fine. But I have not run my code yet. It's probably broken. But, like, there's several things that are probably broken. Reintroduce a step in caps from third round. Hash the randomness was using this is before it's using it. Oh, yeah. Did not reintroduce. They're basically like, use the random generators that we told you to use. They're good ones. Yes, I wanted this. Yes. does not require, yes, in CCA2, people will call it just in CCA for chems. It's in CA2 for public key encryption. Does not require the ciphertext, but we know it's not for that. There are known security benefits for different security properties than in CCA, but I don't think we knew about them when public comments closed. I think it literally got published, the keeping up with the chems stuff and the binding properties for chems. Just a little too late to be included in this. But it wasn't too late to be included, changes based on that to be included in Fips 203. Yeah, the change to not include the ciphertext. Yeah, it's because one, you don't need it. Two, they're not really throwing shade. I talked to one person and they basically were like, I tried to make the case for not necessarily including the ciphertext back into the internal KDF of Ml-Kem, but other changes like the key structure. You can get better binding properties if you do certain things with the keys so they cannot be resistant against a malicious adversary to get the key binding properties. And they were a bit like, this was really hard. And usually I'm able to make the case and that they listen and we can include it. But it was a lot of change too late. Now that we have the explicit validation stuff in there, I have to read it. But if we have that and people do it, that's at least a stopgap. So maybe we don't have explicit mal binding in Ml-Kem as specified in Fips 203, but we're able to mitigate it. I don't think they're throwing shade. People decided in CCA is the only thing we care about for chems. Only late did people who had a history of looking at Diffie-Hellman, small subgroup attacks, invisible salamanders, or these weird confusion properties start looking at this and just be like, oh, there's other stuff here we care about besides just in CCA. It did come a little bit too late, so that's unfortunate. It would be so great if we can just say, yes, you can do an Ml-Kem, spit out the shared secret, and you don't have to worry about also hashing the public key or including the ciphertext in your KDF. You don't have to worry. You could use the shared secret. It would have been really nice. There are others. I have to look at the spec of Frodo-Kem. Frodo-Kem, as written in its original papers, should give you mal binding for K to PK and K to CT. When you specify the way the keys are formatted, when you give it to decamps and stuff like that, I think it's also a little bit squishy in the way that Ml-Kem has and is squishy, and you can write a proof that says the adversary can win the malicious binding security game. Yeah, it does suck there's no Semver for Fips. Tell me about it, Paul. Semver for standards documents, that's a good idea. And if you're interested in more ideas like this in cryptography, the Community Cryptography Standards Project, C2SP on GitHub, does exactly this. They have documents and they are versioned and they have Semver, and it's exactly the way that kind of modern software people who take care of documents and things that are versioned that have like an API boundary and compatibility issues and all this sort of stuff. They do it like that. It's a very good idea. It's good stuff. All right, I'm going to move through this. It's not going to be hashed in. We are all sad. That's not the thing I'm saddest about. It would be nice if we didn't have to worry about that. But I understand their arguments. Yes, storing a small seed in place of larger keys, because that would give us nice binding properties. Keys can be regenerated from seed values, but that is not required. It's not like how you do keys, and therefore, like, who's going to do it? The people who know and have an informed opinion about if we do keys as seeds, we get this nice stuff, these nice Ml-Kem stuff. But if you're just reading, it's the algorithm for generating keys. Decapsulate thing. You'd be kind of like clued to the value of that, to notice it, and not just, this is how you do opinionated implementations, like in Boring SSL and other places, will inform how people do Ml-Kem in practice. Wolf SSL, Wolf Crypt has gotten some stuff validated recently. I don't know if it's for hybrid TLS 1.3, probably not. I would be curious to see what the first sets of Fips validated implementations do. If they support this, that's great. That gives you better binding properties in practice. If your decaps key is just a bunch of exploded crap, the way it's currently written as an encoding of a key and the algorithm that says Ml-Kem decaps. We'll see. A few commenters raised issue on the requirement for decaps function to implicitly reject on a protocol failure. Yeah, that's how it's designed. Implicit rejection. Almost all of the chems that made it past out of the first round of submission turned into implicit rejection chems. It's an interesting debate to have with people who have opinions about the value of implicit rejection. Implicit rejection is supposed to give you a long, pretty random value no matter what. So no matter if something fucked up on the back end, you won't come to agreement, but if you just shove that into AES-GCM, which you should not do, by the way, you should, instead of taking an Ml-Kem and shoving the shared secret out of it into AES-GCM, use HPKE. And if you have questions about how to use Ml-Kem with HPKE, I have documents in the IETF about how to do that, and I can help you with that. HPKE is the modern way to do hybrid encryption, where you use public key encryption like Ml-Kem or RSA to encrypt a shared secret, and then use the shared secret to encrypt a bunch of stuff. There's lots of protocol nastiness that we've learned the hard way that's addressed and done nicely by HPKE that is not covered if you just shove an Ml-Kem secret into AES-GCM. Oh, and if you do that, if you do kind of the naive thing, it'll always give you something. If it's not going to shove out 0, or it's not going to shove out a null byte that you're just supposed to know, means explicit rejection. And if you don't check the thing, like it's an extremely predictable null AES key or encryption key. So I understand why implicit rejection was adopted by basically all these chem designs. We could have done an iteration on that. Literally, you can output your shared secret, which is an implicit rejection chem shared secret, and a flag. The flag is a Boolean, 0 or 1, that tells you, like, and that's going to fucking fuck up the security game about the distinguishability, about the implicit rejection key in the first place. So I don't know. The other people who have more opinionated opinions about that can make that argument better than I, but this is what we have now. And basically everything that is a chem and almost all the key establishment solutions that we have that are post-quantum just turns into a chem shape. And they almost all are coalescing around implicit rejection. So that's a water cooler or over beers argument to have another time. Can't this all be solved by an IETF portable format specification? It could be, or it could have been solved by the Fips specification, because people will implement Fips who don't give a shit about the IETF. So maybe, but like, it's also, yeah. Like, if your in-caps argument is blow up the thing and parse the pieces that may not be bound to each other, like an attacker can modify your decaps key, that's the malicious adversary for malicious bind, and just be like, no, I'm going to replace the hash of the public key with my old hash of a public key of another key, so that it will output the correct thing because of the way that the FO transform works under the hood, and break the security game and break the malicious binding properties of the shared secret to a public key or the shared secret to a ciphertext. Once you start blowing up the thing out from a single seed, the thing starts to crumble away from the highest level of binding security into something that's closer to leak, which, for the record, it's hard to make good arguments so far. I found it hard to be like, if you had binding security for that chem in this case, you would be protected against this thing versus leak bind. Leak bind KPK and leak bind KCT may be sufficient for general cases. It's kind of early to say that definitively, but we'll see. Implicit rejection means you don't have to check return values. There's also weird proof things when I'm a fake cryptographer. Proving the in-CCA security of the FO transform period, there's several flavors of it. There's explicit and implicit rejection. They're all flavors of the FO transform. is a difficult proof, period. Because I was like, oh, I have done such and such a proof for Ml-Kem or Kyber or whatever it was. And I said, okay, my next step is I'm going to prove in CCA of the FO transform Ml-Kem. Every other cryptographer who's looked at this has been like, have fun with that. I'm like, never mind. I think implicit rejection makes the proof nicer, easier, more elegant, and simpler. But the proof itself for FO transform is just a lot. Other people who are better at proofs than I am do that. I haven't done that. Hello, David. Relying on the IETF to solve this is not always a good or fast idea. I very much agree. And this is slower. Yes. We basically already asked them. We asked them while they were doing this, and they were just sort of like, too late, but also we weren't convinced enough to make it happen. It wasn't too late. Now it's too late. Like, it's done. It was maybe too late a month ago when, like, people were like, oh, yeah, the thing's done, and now it's with the lawyers, and it's gone up the chain to the Secretary of Commerce. It sucks. Maybe we'll do something in IETF that some people may use, but there's going to be a Cambrian explosion of like, okay, well, there's Fips 203 Ml-Kem, and there's IETF compatible Ml-Kem. We'll see how much it matters. Increase the seed size. I think, yeah, 32 bytes sufficient multi-target attacks. Okay. Failure rates. I'm going to skip all the way into Fips 203 now because I'm very informed about all of this, and I'm less informed about everything else. So this is the official Fips 203. Some problems between Fips 204 and some of the IETF signature stuff we'll have to work out. I'm not surprised because they differ. There's enough difference between Fips 203 initial public draft, which is this one, and the final Fips 203 that I have to go change a bunch of code. So anyone uses non-IETF Cha-Cha Poly? I don't know. Probably. I have a feeling that libsodium may use the non-IETF Cha-Cha Poly because libsodium is an old project at this point. And I don't know when the IETF Cha-Cha Poly was written down. That's a good thing to investigate. If I was going to guess, probably that. And lots of people use libsodium still. All right, so this is Fips 203 draft. And this is the real Fips 203. I'm just going to do it the original order. Yeah, they do X also. And look at that. It's a real standard with Secretary Raimondo's name on it. That's pretty cool. Series. Go talk to someone else, like that guy. Although they said elsewhere, talk to Dustin. Or Dustin. Set of algorithms. They changed a bunch of stuff. Modeling, problem. Believed to be secure. The fonts are different. Hero boy and girls, yes. It's a real boy RC the way that, you know, Pinocchio became, I'm a real boy. All right, let's go. Used or operated by federal agencies or by a contractor or an agency. This will be applied to national security system via CNSA 2.0, which is elsewhere. And it's also kind of like not as hardcore lockdown as these Fips things. It's kind of like a smushy kind of thing. Modern computer sans, LaTeX. Well, I don't know if I guarantee you that this thing was generated by LaTeX, but I would be very surprised if it was not. If there's some other thingy that you can use that's not secretly LaTeX under the hood, that's cool. Software, firmware, hardware, or any combo thereof. Conforming implementation may replace the given set of steps with any mathematically equivalent set of steps. This is like a non-trivially load-bearing phrase. Root seed that you put through like TurboShake and generate like the two seeds. And then from that, you generate like the K, PKE, decryption key, and all the pieces that you need. If we slide that in, does that count as a different procedure that produces the correct output for every input permitted with a mathematically equivalent set of steps? We don't know, and the answer is going to be, if you can get it Fips certified, it will be. Real PDF bureaus. My browsers are my PDF viewers. All the ones that aren't browsers crash on me. Thanks, iPad. NIST uses Word. Does that count? Ask your validator. Developing a program, and then this is not on github.com, but I'll go look anywhere. Patents. 2 patent license agreements. Freely available practice by anyone for Ml-Kem is published by NIST. I wonder if that will affect anyone trying to do things in the IT. Implementation schedule effective immediately. Qualifications. Including randomness used by the 2 parties. Decaps key, shared secret key. Yes. This is funny because this is extremely like IETF vibes, but like this shall, which is lowercase but bold, and it's a shall, is like the equivalent of an IETF uppercase must, as opposed to IETF uppercase should, which is weaker. General performance design. Any module that implements key establishment capabilities designed and built in a secure manner. Alright, set your calendar for about 5 years from now, and we'll just put this one and any updates side by side and see if anything terrible pops out. Yeah, exactly. This is how you're supposed to cite it. So, this was the first... Sorry. Where'd it go? Is it here? Yes, it's here. 21 algorithms in the final compared to 17 in the initial public draft. I think it's just mostly the internal variants and then maybe one more thing. They did remove, it was algorithm 8, but I think they had bit rev 7 or whatever it was, and they didn't list it. It was just sort of like a subset of NTT or something like that. But, alright. We've got a lot of context. Below, fresh random value equivalent process. Fresh random value output for a random bit generator has not been previously used. I'm going to try and blow through this. Requirement. Strong recommendation, but not requirement. So at least we align with IATF on this. Important, but, you know, itty-bitty little building block things. IPR, IATF, no IPR statements on Fips 203, add IPR. That's my stylistic opinion. Like, that's a function very similar to all these other algorithms. Although, R mod M, you can have piles and piles of code implementing R mod M. I don't know, whatever. Transpose. This is another thing. There's a ton of stuff in here that's literally just like linear algebra. Some of the stuff is really laid out, like bits to bytes and bytes to bits. And I guess for endianness that matters. But there's other stuff that's kind of this pure math stuff that is glossed over. I'm pretty sure they're keeping it that in here. Just transpose this matrix, you know, do a matrix multiply. And I'm like, there is a lot of literature about how to do an efficient, secure matrix multiply. So you could just write it down and they're like, nah, it's fine. Figure it out. I understand that you can't put literally everything into a document like this, but maybe that's where you get the equivalent mathematical computation stuff in there. You can just hand wave that away and be like, yeah, we're not going to explicitly write this down because you have a lot of options for that. And it's like, okay, fine, but you could take a lot of question marks and hows and, you know, which way should I do this? You could make it really easy for people. And you could just make like, here is a implementation of transposition, matrix multiply, whatever. Because they do the NTT transform. The NTT transform is extremely important, but it's also kind of like very similar. There's a lot of wishy-washiness, sloppiness regarding why, when they are using matrices or elements of the matrix in the draft at least. Yeah, I agree. I am not an author at Fips, but when I have authored similar documents, we put a lot of stuff in there about how to do stuff like this, but I don't know, whatever. Like polynomial stuff. Like when we were writing Frost, like just a lot of language about literally how to do simple polynomial operations. 2 minutes ago, NIST said they'll have updates 203 for errors! Are we over here? We're over here. Thanks, Paul. Oh, they already have something that was already certified? Cool. I'm gonna look at those and see. Spec should be executable and specified in formal lang. I very much want that to be true. Might be incorrect. I very much want that to be true. If you've seen the hack spec stuff, hack spec has turned into a compiler that will take standard Rust and compile it to F-star, EasyCrypt, Coq, whatever. And so you can write an executable spec, an interoperable executable spec in Rust. Then you can translate it and do all these formal guarantees and proofs about it. It's like a formal language, which is probably our best bet. Because if you write your specification in a formal language, you're going to have to translate it anyway. A lot of people can't use F-star, Coq, Cryptol. A lot of them are like, I like Python. Can you write me some Python? Humans are the hard part in all of this. Like when you try to have the humans do math and formal correctness and formal specification, it's not the formal specification. It's the fact that humans also have to use it in other areas and there's translation involved. The humans mess everything up. These are cool. I'll look at these later. Adam Langley. I'm guessing he helped write some of the stuff. Oh yeah, Boz is already looking. Yeah, I forget who was saying like they're not up to date. One, they're incorrect, and two, they don't implement some of the new stuff. Interesting. Internal functions. Sure. Yep, I agree, Marku. I think they said they weren't doing pre-hashing. I'll probably look at MLDSA, not today. I'll have to drop in like 20 minutes anyway, but I'll come back. I haven't even looked at SLHDSA at all. Force those functions to greater prominence than is wise, do not always cut in the sensible place for exposure. In the spec, they explicitly say these are not supposed to be public functions. These are supposed to be internal functions. The only public interface functions are supposed to be keygen, decaps, endcaps. It's forcing your implementation, your module, into a kind of funky state. Pre-hashing covered in new MLDSA. Is it covered as you can do that over here? Or do they specify, here's the pre-hash variant, or here's a pre-hash parameter set of MLDSA? Because, for example, in ED 25519, there's how you do it with pre-hashing. There's a plethora of cipher suites of parameter sets of how to do EDDSA because it explicitly supports pre-hashing. I'll go look at that later so you don't have to answer if you don't want to, if you don't know. Blah, blah, blah. Specified domain separation constants to prepend and allowed algorithms for pre-hashing. That I like. That's the way I think one should do it. And basically say, instead of parameterizing it, they're not giving it the same kind of prominence as the other parameters. MLDSA is whether you're pre-hashing it or not pre-hashing it or whatever, like MLDSA is MLDSA. And if you are pre-hashing, that's sort of outside the boundary of MLDSA. This is all very kind of fuzzy and like, where does this even matter, and kind of like where you think the boundary is. But I like the way they did that instead of what ED 25519 did years ago. Same mismatch as the server code. This doesn't diverge from specification. Doesn't cause tremendous interoperability problems with applications that attempt to store private keys as seeds. But we want that to be an option. So yeah, bugs happen, but perhaps rushing to obscene certificates before there's too many eyeballs on the golden reference is not wise. We put in a fix that should go out either later today or tomorrow. Another user on the forum pointed out similar issue for Ml-Kem keygen under PK keygen. In most cases, matrix dimensions are added to the seed and then hashed to form the key material. Yes. This is different than the draft Fips, but covered in this. This is the rank. This is K, right? And hashed to form the key material. I can't just search for K. Shell. Oh yeah, modulus is 3329. Right, okay. There was some input validation. Type check and modulus check. That's not a lot. This is the draft. Initial public draft. In caps, decap. Okay, I'm not 100% sure where that was in the initial draft. Interesting. We got bugs, but we found them. Yay! Anything I missed? EQC. Oh, that was weeks ago? Okay. Alright, pseudocode. Yeah, data types. Pseudocode is agnostic to how mod M is represented in actual implementations or how modular reduction is computed. I know that this is like a modulus of 3359 or whatever it is, 29. But I don't love that. I kind of wish they were a little bit more, like, recommend-y. Arithmetic. Yep. Yeah, that's right, algebraic objects. Let me tell you, I've become very familiar with the little Unicode thingy here that lets you literally do character and then paste immediately this little thingy after it to give you F hat and A hat and G hat and all that sort of stuff. Unicode's amazing. Okay. Yes. Serial multiplication. This is nice. I don't think they had this much fleshed out in the first draft. Never thought I'd hear this. Unicode is amazing! Unicode's great. Just have like the one true encoding, which is UTF-8, and then you can turn it into bytes. Pinata of bugs. Well, I believe you. I like to make pretty characters with it. Arrays. Arrays, but not vectors. An array might be a polynomial ring element. It might be some random bytes. It might be a vector of polynomial ring elements. It might be a matrix comprised of vectors, comprised of polynomial ring elements. I want types. In my code, where I get strong typing for free, I have a lot of types. Lots of types. All these different arrays are distinguishable and non-confusable at compile time in my code. But in this stuff, it's just all arrays. I understand why, but I'm just like, Or a matrix of one column. Yeah, it's fun. I understand why. Not everyone gets strong typing for free, but they should just use a good language. Multiply my NTTs. Did that. I don't think this has changed much. Like, they literally use the word transpose 3 times in this final standard. And they just sort of do there's like a very load-bearing, where is it? It's down here somewhere. They just have a little annotation floating around. A little T. Yeah, here we go. It's going to break the test vectors if you do a shitty implementation and you miss that. If you don't use the transpose of the NTT domain matrix A to do this dot product or whatever, you won't pass the test vectors. But I wouldn't be surprised if I saw a blog post or a bug in the future. Did you know that this requires a whole linear algebra operation to make sure you're doing the right thing? Because you have to write a specification for the next 20 years, and we've got like 40, 50 years at tech debt that we also have to be able to make sort of work with, like C++ and maybe COBOL. All right. I'm going to skip ahead. All of this looks similar. I've written the whole Rust library to do transpose. Isn't quite complex to do efficiently. Not surprised. I am surprised that there's a lot of linear algebra that's just sort of figured out, you can do whatever in this thing. If me, I'd be like, here is a way to do it. Here is basically every algorithm. Like, I've done stuff that highly rely on modular arithmetic, and then was just like, you need a thing that does this. Go get your elliptic curve library, go get your hash function. But the stuff you're implementing here, like the matrix vector and the polynomial ring elements representation, is all like, when we were doing polynomials for our stuff, we're like, here's how you do it. It's all mod whatever, but here's the algorithm of how to do it. People put out a thing and it was floating around for a year. I'll go back at the comments. I don't think people said, please include an algorithm to do transposition. Please include matrix multiply. Please, like, I have a feeling that if there was like a wave of public comments that said, please include the linear algebra, like a linear algebra implementation of these common things, maybe they would have done it, but they didn't. Here we go. This is the scheme. And yes, the assumption is that module learning with errors is hard in this instantiation by Oded Rogev. These include a copy of Hacker's Delay into Computational Algebraic Number Theory with Fips standards. Yes, with the standard that says read these first. Noisy linear equations, secret variables. The task is to recover X. Noisy equations such as standard algorithms, Gaussian elimination are intractable. Yes. It's basically a trapdoor. Difference is in MLWE. Z sub Q, N is replaced by a certain module. R sub Q K, which is constructed taking the K-fold Cartesian product of a certain polynomial ring RQ. And then you transform it into TQ because it's faster, and then you go back. The secret MLW is an element X of the module. The ring RQ is discussed in detail. PKE, which I'm pretty sure one of my co-authors wrote a proof of the collision resistance of the PKE underneath MWE, and it's very lovely to be able to build stuff with that. PKE is converted into key encapsulation mechanism using FO transform. Let's see. Do certain properties of FO transform ability can significantly more general attack model than the PKE. Similarly satisfy in CCA2 security. I like how they're like so-called in CCA2 security because in CCA2 is technically like about PKE, and then people have been like, when you're talking about a chem, there's only really in CCA. Yes, PKE first. Transformation PKE to Ml-Kem was crucial. NTT. So nice. With linear polynomials. Yep. I still don't understand why that works. Like, I haven't even tried to understand, like, why it's fine. But it's just sort of like, oh, that's neat. I believe you. Provable crypto was a mistake. I feel like we had a lot of mistakes way before we had the provable crypto that we deployed in practice. As long as we have something, just a foundation. Formally. Oh, decaps rates. Yep. Professor so-and-so. Terminology requirements. Yes. Okay, PK is only a component. You might think, well, yes, obviously, why is this a top-level bullet point? Because people have been asking, hey, what if I use just KPKE for a certain little thingy in TLS because all I need is yada, yada, yada. And if we've already got Ml-Kem over here, I'll go into the guts and use this component for this other thing over here. And it's like, nope, nope. Nope. No one has analyzed it for that. Everyone has like, yeah, exactly. Like, no, just NO. It is internal. It is private. It is only in CPA. It is only chosen plain text attack secure. It's like, now it's been proven to have a collision resistance, but that's not CCA. Like, it's just NO. If anyone says, can I just tell them NO, the spec says no. Figure it out some other way. Use pure Ml-Kem. Just use it straight up. And if they say it's too expensive, just be like, show me how it's too expensive. It's cheaper than X25519. Hey, if you want some fun, if you want post-quantum fun, let's go ski sign. There's loads of fun in there. Smoking husk of SIDH and psych. Don't pay attention to that. Ski sign. Let's go. I don't know if Bleikenbacher has really paid attention to any of this Ml-Kem stuff or any of these chems. That'll be fun. I don't know if he'll find anything, but I'm curious. Shall not be used as a standalone cryptographic scheme. Only as subroutines. Yes. Controlled access to internal functions. Yes, please. Interfaces for these functions should, remember, shall is like IATF must. And should is like IATF should, which is a strong recommendation, but not a requirement. Sampling of random values required for keygen, specified keygen encapsulation shall be performed with the cryptographic module. That's the most important part. Equivalent implementations. Specified algorithm may be replaced with a different procedure that produces the correct output for every input, where input includes specified output input as well as all parameter values and all randomness. Approve usage of the shared secret key are always 256-bit values under appropriate conditions, and that these values match can be used directly as a shared secret symmetric cryptography. Further key derivation is needed. Final symmetric keys shall be derived from this 256 shared secret in an approved manner. Their whole deal is cryptographic module verification program. They can only test what something does, not what it does not. They can say must or shall. They can't say shall not. That's just not how they do it. That makes sense. As discussed in Ml-Kem as an NCCA2 secure chem. A combined chem that includes Ml-Kem as a component might not meet NCCA2 security. Implementers should assess the security of any procedure and should the key derivation methods of SP856C are applied to Ml-Kem in combination with another key establishment procedure. More guidance regarding chem is given. Looking out for you. Yes, randomness, input checking. Require input checking. Shall ensure they're only executed on inputs that have been checked. That will save a bunch of asses. FF for the win. FF? Finite field? 2 exceptions to this rule. Yes, this is what was asked for. Firefox. Yes, the Firefox PDF viewer is S tier. Whenever I say language that's not from my cohort, I feel like a huge poser. I will go and be, I know there is a hyperlink here. This PDF viewer will not show it to me. And I will open it in Firefox, and I will, just to open the same PDF, get the hyperlink, put it in whatever thing I need to link into subsection of the PDF. It is also memory safe. Hell yeah. Exactly, David. Well, you're younger than me, so you're allowed to talk like that. It's not cringe. The seed, D and Z, can be stored for later expansion. If this seed was just the root seed of both D and Z through an expander, through XOF or whatever, or TurboShake, can you do Ml-Kem in a very secure binding properties way? Or at least it would be allowed, it would be Fips compatible. I'm curious how it's going to shake out. Decapsulation key, sensitive data shall be treated with the same safeguards as the encapsulation key. Yep. The matrix A hat can be stored. Matrix A is also generated. Matrix A has data that can be easily computed from the public encapsulation key and thus does not require any special protections. This is interesting because a lot of people were like, why are we doing this all the time? Because it's a lot of computation to regen or do it once and haul it around when it's public data. Like, NIST could have be like, here's a seed, this generates a hat, this is the matrix for all these different parameter sets of Ml-Kem. A lot of people would have trusted it, but they are regenerating it fresh every time you do a keygen. It's interesting. It's easier to do trust-wise. It's cheap enough that we can generate a fresh new matrix with this distribution to sample the randomness. And it's cheap enough, and we trust it enough, and we understand it enough that we can just do that. And we have one thing of trust that we don't have to worry about. Unlike an elliptic curve group or a generator for an elliptic curve group. You have to make sure that you pick that nicely because we know that there are ways that can go wrong. But it's expensive, and you don't have to do it. You could have just picked it, and it would have saved stuff for people. Some people are still grumpy about that. I don't know. Like, sure, whatever. There's a shall not refloating point, which is implementation but justified given without the start floating point. Yeah, I agree. Interesting. I should talk to more NIST people. I'm curious about that sort of thing. Maybe one of them will be at crypto. Maybe I'll run into someone and just be like, oh, this really nitty detail. Oh, here's the floating point. Shall not. Okay. In all pseudocode in this division is performed without floating point arithmetic, ordinary integer division computes all these things for non-negative integers. Whoa. I'm going to stop there and try to come back in maybe 2 hours. I'll tweet and post and come back to Fips 203. This is my #1 Fips baby at the moment. Matrix 3, yeah. Ml-Kem, and then if you didn't find one that you liked, Ml-Kem rocks +1, Ml-Kem rocks Concat 2, Ml-Kem rocks Concat 3. Hi, Strat. You can watch the recording. I'll start again. Not use floating point is testable. Thanks for. I'll come back. Cheers. Happy